Hello, it's Mrs. Golding. We're going to look at Friday paper 23, and we are doing starting with number 5. So it says find the sum. So we're going to add, let's not move that around. Find the sum. We're going to add these two numbers which are written in scientific notation. And when we are doing that, we have to follow our exponent rules. And when we're adding with exponents, those exponents need to be the same. So in other words, we have a common base here and here, and then we have exponents, but they're not the same. And so we have to change those exponents to make them the same. Now, as you can see, I can either make this the first one a 5 or make the second one a 4. And I have to follow these rules. And when I explained it to you when we did this earlier in the year, I used LARS as a way to remember that. Left, add, right, subtract. It's just a way to kind of remember this. The principle is I have to maintain equality. And so if I'm going to take, for instance, let's just take this one. If I'm going to take this number, 6 89/100 times 10 to the 4th, and I want to change that and I want to increase that exponent. So I'm multiplying it by another power of 10. If I don't change where that decimal point is, then I'm just changing that number altogether. But if I do something here where I move this decimal, for instance, if I go left with the decimal, I've made it 10 times smaller, haven't I? 0 or 0.689 times 10. If I leave it to the 4th, then I'm no longer going to be equal, right? So then I'm going to change this because I went left. I'm going to add. So 4 plus 1 is 5. And now these exponents are the same. So I'm going to now just put underneath 9 24/100 or 240 thousandths times 10 to the 5th. And I'm just going to straight up add. So 9, let's just go 9, 8, 9, 10, 11, 12, 9. 9 and 929 thousandths times 10 to the 5th power. So that is going to be my answer for number 5. Notice I added them only after I had common exponents. All right, back to our Friday paper. I'm on question number 13, and it says 7 raised to the power of -2 plus 8 to the 0 power. So when you have any number and you're raising it to the negative power, it's like I'm taking that. Let's see what it would have been if it was 7 squared. That would have been 49. And 7 to the 1st is just 7. And anything to the 0 power is 1, right? So 7 to the 0 power is 1. So you kind of see a pattern here. So 7 to the -1. So that's going to be 1 over 7. My head is in the way here. 7 to the -2 is 1 over 7 squared. See the pattern? And 7 squared is 49. So I'm going to take 1 over 49 plus 8 to the 0 power. Anything to the 0 power is 1. So the answer is 1 and 1/49. Or 49 times 1 is 49 plus 1 is 50 over 49. Either of those, okay? All right, let's do the next one. 5/6 times some number, or 5/6 of a number, is -15. So I want to find that number. So I'm going to undo this multiplication with division. So I'm going to take 5/6 times something gives me negative 15. If I divide by 5/6, isn't that the same as multiplying by the reciprocal? Keep it, change it, flip it. So I'm going to do the same thing on this side. When I do it here, 6 and 6 become 1 and 1, and I'm just left with A, right? Identity property. So here, 15 and 5 have a common factor of 5. So 5 divided by 5 is 1, and 15 divided by 5, negative 3. So now I just have negative 3 times 6. So it's going to be negative 18. So for number 15, we have negative 18 as our answer. A equals negative 18. Okay, let's do number 18. So we've got our equation here, and whenever we see those parentheses, we got to kind of think of that distributive property. So we have negative 4 times x is negative 4x, and then negative 4 times a positive 3 is a negative 12, and then we have 2 times x, and then we have 2 times negative 3, and then I have plus 12. So now I'm going to look and see if I can combine any like terms that are on the same side of the equal sign. So those two constants can be combined. So I'm going to rewrite negative 4x minus 12 is equal to 2x, and then negative 6 plus 12 is a positive 6. Now, I like to work with I switch around. I'm going to work with my terms that have a variable right now. So let's just keep things positive in our lives because we want to be positive. So we have negative 4x and positive 4x are additive inverses, so they make 0. So negative 12 equals 6x, 2x plus 4x is 6x plus 6. We can subtract 6 from both sides. Positive 6 and negative 6 are additive inverses, so they make 0. And that's negative 18. Divide by 6. So x equals negative 3. Boom. Okay. One more problem. What is the rate of change of the following? And rate of change is code for slope. So what is the slope? Well, this one is pretty easy to find. Y equals mx plus b. And we're looking for the m. We're going to choose, let's undo this. Just the negative 3. So 19, negative 3. Or negative 3 over 1. Now, the slope here is a little harder to find. That's the rate of change. But all we have to do is find the change in y and put it over the change in x. So from 2 to 4, we add 2. 4 to 6, add 2. Add 2, add 2. It's constant. So the constant rate of change tells me this is linear. So it's going to make a line if I graph it. Minus 4, minus 4, minus 4 every time. So my change in y is minus 4, and my change in x is plus 2. So what's negative 4 divided by 2? Negative 2. So my rate of change is negative 2 or negative 2 over 1. Okay? All right. Hopefully that's helpful to you guys. Hope you have a great day.